Good evening. I'm going to write a test tonight. And that's one of the things that's quite strange about this, learning Haskell and live streaming it, is I haven't really been writing any tests. And I'm normally a writing the tests kind of person. I would typically do quite a lot of TDD when I'm writing code. And I haven't done that so far with this Haskell learning. I think there are probably a few reasons for that. One is that I just don't know what I'm doing. A lot of the time I'm just looking up Haskell functions, and that's not really, it wouldn't really be helped with TDD. I guess one reason is types. I'm using types in some of the places I'll be using tests, I think, to check that the behavior has certain characteristics that I want. I guess I would use tests for that sometimes. One reason is probably the REPL. A lot of the time I've been getting that sort of fast feedback loop by actually just playing with the code and seeing if it does the right thing. A lot of the time I'm writing tests to gain confidence that the code I've written does a particular thing, and I can get that in other ways. But maybe fundamentally the stuff I've been writing has not had complex behavior or interesting behavior, largely speaking. It's much more been about learning how to do something quite simple in Haskell rather than learning how to build something quite complex. And that's probably where tests becoming more useful. But there was a case at the end of last week where I was writing a function to remove a list of names from my shuffled list, where the behavior was just a little bit more complex than I'd anticipated. And I got it wrong a little bit. So what I'd like to try and do this week is start by writing some specs for that behavior, and get to the point where they're failing, or I can pick up some bugs, and then use that to drive, or at least to gain confidence that what I'm doing solves the real problem. So let's have a look at the problem we've got. It's to do with this remove function. But maybe actually, can I bring up Scratchpad? Give this in advance. Bring up Scratchpad. Okay, so we have a list of people. So let's put some people. Let's put in Beppy, Boppy, and Bippy, I guess. Those are my three people. So imagine this is our list of people that we're shuffling, and on top of that we have an index as well. So an index, well, it's actually an offset. So an offset of 0 would say we're at the first person on the list, and 1 would say we're at the second person, and so on. So imagine we're in this state where the index is 1, which means that we are currently pointing to Boppy. And then we want to delete some people from this list. Not many people you can delete. But we'll treat it one at a time. So you're going to remove one person from this list. There are actually a few different scenarios here. And it behaves slightly differently depending on that scenario. So if you're deleting somebody that comes later on in the list, so in this case Bippy, all we need to do is create a new list where Bippy is not present. We don't need to worry about the index, we don't need to change anything else. We just say, if you're removing someone later on, just delete them from the list, return a new list without them in it. It doesn't matter where they occur, as long as it doesn't matter how much further on they occur, as long as it's after the current element. If you're moving someone before the current element in the list, so in this case removing Beppy, it's slightly different. So we obviously return a new list with Beppy removed. The trouble is now the index is wrong. It's saying the offset is 1, which would change the current person from Boppy to Bippy. And that's not what we wanted to do here. We just wanted to remove someone from the list. So if the person we're deleting is earlier in the list, we should also, as well as removing them, we should decrement the index. And then there's another case which gets a little bit more interesting. So if the index here is 2, so we're currently pointing at the last person on the list. In fact, let's look at the case where the index is still 1, or the offset is still 1. So we're still looking at Boppy, and Boppy is the person we want to delete. Now, in this case, where Boppy is not at the end of the list, it's quite straightforward. We just delete them. the index or the offset stays at 1, which means it's now pointing at Bippy, which is probably what you want, right? You're not going to go back in time in the list. So you want to point at the next person that's available. But if the index is set to 2, or the offset is set to 2, so we're currently pointing at Bippy, and we call delete, so sure we can get rid of Bippy, we turn a new list without Bippy in there, but we can't leave the offset pointing here, because then when we try and say, show me the current person, it's walking beyond the end of this list. So in this case, we want to go to the next person, but that's actually the first person in a shuffled list. So this would have to be reset to 0, and the list would be shuffled to get a new randomized list. So I think those are the 4 scenarios we got. So we got deleting someone after you in the list, deleting someone before you in the list, deleting the current person when they're not at the end, and then deleting the current person when they are at the end. So those are the 4 things, the 4 scenarios I'm going to set up in my tests, and then we'll see if we can make the code do the right thing. Don't save this. Okay, so I think when I generated this, there should be a test file. Specs file. Okay, cool. So when I ran stack new, I used the standard template, and that created a spec for me. Do I have anything set up to run the tests? Run test task. Configure tasks. Okay, I need to put a new one in place. So this is the build task I currently have in place, but that's not the one we want. So a little bit of VS Code admin first, I guess. We're going to say label, label is test, type is shell, command. I'm going to play that. Command is stack test. Then what do we do? Presentation. Yeah, put this block in. So presentation. We'll do echo. I don't really care if it's true or false. Reveal always. Focus is false. Panel. I'm going to give it a dedicated panel so that the output is always together. Reuse message. I don't want that because I know how to reuse it. And clear will set to true so we can see our output each time. Problem matcher, I think I'll leave empty because it doesn't. There's no problem matcher for Haskell built in, and we'll do type test is default true. Okay, I think that's enough. So I go back to here and say run tests. I have no key binding for that, annoyingly. It does hopefully run the test and should say, yep, here we go, test suite now implemented. That's cool. Well, it does the thing. Do we have access to hspec? What am I doing? Hspec would be like that. I'm just going quickly to an example here. Doesn't say what package it is. No, it says here with hspec, capital H, lowercase spec. So it couldn't find it, which means I probably need to go to package YAML, or not package YAML, yes, package YAML, because it gets turned into the cabal file. In tests, I can say dependencies include hspec. I don't know if that's going to work or not. Oops. I'm going to say stack init, stack build. Stack build should be enough. I'll see if it just goes and installs the dependency for me. Maybe need to say stack test for it to check those dependencies as well. Or maybe it's just available. No, here we go, missing dependency hspec. That's good. Okay, so it's going together. Oh, and that's going to compile. This is where I should have bought a faster machine, but too late now. Okay, so we should be pulling in hspec. but we can start fleshing out a basic spec here. In fact, while that's building, let me just go and grab an example. So it's hspec and then describe something and then do something and then actually do it using should be or should equal. So we can say describe, what are we describing here? We're describing delete or remove, it's remove. And then we can say it removes people later in the list. And then in here we can say, okay, this is finished now, so we should hopefully have access to hspec. I'm just going to quickly restart the LSP server. I just need it to import hspec for me. Might say module main. That might help, won't it? Could not find module hspec. Oh, that's annoying. I might need to fix the language server. I might need to add that to the non-test bit of stack. Don't know. Oh, that's not the case, but let's try it. Maybe I should add it here actually, just add it to overall dependencies. I'm not sure, to be honest. I just want to make sure the language server picks it up so that then it doesn't complain at me here about not finding it. I don't know if that's going to help or not. This is good. I've now made everything quite unhappy. I keep flashing this out, so that didn't help at all. Good. Delete that. Maybe we didn't need to import anything after all. It removes people in the list, and then in here we can say remove. Not in the scope. Okay, that's kind of what I want. Oh, test at hspec. That's what was going wrong. Add it to there, and then remove. Ooh. We're going to pull it from actions. Okay. So remove should be. We're going to remove here. So we're going to remove someone. We'll remove Bippy from our state. And then that should be a new state. In fact, can we just reuse S here, I think, to build a new thing? Let me just remind myself what the state looks like. So state has got file name we don't care about, index should be the same, and then names is the thing we're going to change. Names is equal to a list of Beppy and Puppy. I'm not sure what these people are called. Where S is equal to auto state file name equals whatever, we don't care about file name, index or IDX? IDX, should have called it index, yeah, or offset would be more accurate. So IDX we're going to set to 1, and names we're going to set to Epi, Buppy, and Bippy. Right. So let's pull these things in auto state. Oops, not that key, that key. Yep. Import that. I call it file with capital N. I did stuff. Gonna make that explicit. Okay. Right. What's its problem now? With nothing. So expected type is spec with, and the actual type is spec with, and then some more stuff. A0 is ambiguous. So I think it might be to do with this. I'm not sure. No, it doesn't look like it's anything to do with that. Let me just go and grab the example of the spec. So read something should be whatever, and then type. But it should know the type because I've told it that it's S. Like down here, they haven't had to tell the type because it's obvious. So here, type is IO. Let's make that bigger actually because I'm streaming. hspec do, describe, blah, do, it something do, and then some expression should be some other expression. So I'm saying remove BPS should be names should be that. Can I not do it? If I is it to do with the was that? No, it's not. It doesn't really make a difference. That's annoying. So let me just make this simpler. So S should be S. Oh, hang on a second. I didn't have should be. That's pretty what it was. Right, let's try that. So add that. We're getting better. Okay. So what's the problem with this? Shouldn't need that because it should be able to work it out. And I believe it's not that. Couldn't match type IO with actual type auto states, but it like it should be to return from should be here. In the second argument of should be, in the second argument of should be, okay, the second argument of should be is this overriding of S. Again, just make it a bit simpler. Is it? Oops. Is there anything I'm doing wrong here? Nope. Let's go back to example again. Something should be whatever. Transfer from the list. Head of something should be 23. So I'm not quite sure what's wrong here. Let me just grab this for a second. Maybe this one. See if that works. Want one of those lines. So I just take these and comment them out. Comment. And then these lines and comment them out. Totally fine with that. Okay. So what's different here? Main IO is the same. This is the same. This looks similar. This is nested scribes. It looks the same, and then there's something wrong with where I've written this. Okay, back to here. Nope. Interesting that it didn't know how to show this. Is there anything wrong with my where clause? I don't think there is. Can match MTIO with actual type list of characters. But I don't understand why. Well, hang on. Let's make sure I've got enough arguments passed into remove for a second, because that might be wrong. I just put it back to the way it was, so it should be Beppy and Puppy. I jump to remove. So remove takes list of names and the state. Oh, it does it under IO. Okay. Well, that shouldn't be a problem though, because we're already under IO. But maybe it is a problem. hspec IO. Unit testing IO actions. That's actually what we're doing. What's the answer? Give me a quick answer. This is a bit more complicated than I wanted. It says they're not really running under IO, or not straightforward under IO there. This is quite a long answer. Oh no. Right, okay, so we need to do something. Well, I don't even need to, but right now I'm going to do something that's not under IO temporarily, and I'll make it do the same thing. The trouble with this is the shuffling, I think, because maybe shuffling needs to be under IO. Yeah. So I kind of need a pure version of this that's not doing shuffling. Okay. That's awkward because the final scenario I want to write does actually shuffle things. So maybe shuffle, what's it doing here? Why is it under IO? partly because it's seeding it with get current time, which I think needs to be in the IO. So if I could pass in the seed somewhere, perhaps in the state, then I could make remove pure. I can make this pure. And then I can move the generation of the seed back to main function. Okay, it's going to be quite a big refactor just to get a test working. So let me see if I can get the test working first. And then if I can, I'll come back and refactor everything. So I'm just going to call this remove prime for a second. I'm going to go list of names. It's an auto state. Under an auto state, sorry. What does save state do, out of curiosity? Oh, it's actually, see, this is not cool actually. This function is just side effecting too much, both in terms of generating a random seed, but also in updating a file. And what it should really do is run it under state, I think, much like that's doing. If we did something like state, auto state, I think that's right, and then we can say remove. Let's put under another mode, under another computation, but why not, eh? So what's it going to do? See, do I necessarily want to call run state? It's maybe a bit complicated, more complicated than it needs to be. No need to use the monad here, because I'm just going state to state. Let's keep things simpler. Okay, so we don't need to do block. So we got names and we got the initial state. And we'll just check away names for a second. Okay, this doesn't do anything, just ignores the names, turns to state. I'm going to export this and then change the test to use it and see if I can get the test working, and then we'll drive out the functionality from there. So we'll change it to remove prime. Okay, cool. So now we don't know how to show auto state. So we just go in here. We got the state type. We can say deriving show. Okay, it doesn't know how to check equality. Can you derive EQ? Yep, because there are just strings and lists of strings. Okay, so will this work? So we're going to say remove Bippy from this list. Should be Beppy and Buppy, but it's not, presumably. Let's try running the test. Example 1 failure, and that's cool. So we expected Beppy Puppy, but we get Beppy Puppy Bippy. Fun thing to say. Okay, so I can now go and start to implement that, I guess. So I wrote this without before, but I'm pretty sure there's going to be something built in Haskell to remove something from a list. So we're going from list of A to another list of A. Give it a minute. There's quite a lot of things to go from lists to lists, I guess. Reverse cycle, init, tail, drop one, drop end. I think I looked last time, didn't I? There was nothing in the list that I could see that would remove an element from the list. I'm sure there is something, I'm just missing it. It's not a fold. It's not a scan. I'm going to take, drop some numbers things. Isn't there something like 8, 8, 8? Oh, that's a good point, actually. Yeah, I do need to know what element to remove. Default it's like the opposite of, no, it's not actually, it's not the opposite of cons at all. Delete. Delete removes the first occurrence from its list arguments. Thanks, Will. Okay. Deletes the first occurrence. Probably good enough. Yeah, so let's go for that. So we can say delete. In fact, we just say delete. For now, it's not correct behavior, but it will suffice for now, I think. Okay, we're going to, actually it won't suffice for now, so, oh, I've taken a list of names. That's okay. So we can go names and state, and we can delete names from state, except that we can't because n is a list of names, so we could copy this function. Out. So we're going to say s and names is without n names of s. Oh, it seems to only want to indent a little bit. Okay, so that, I'm going to look this up to see if there's something that does this, but yeah, we should take the first, I think we should just strip out any names we pass in from that list of names that we were given. Oops, wrong thing. Back to here. And let's run the test again. Okay, so we can another test from the scenario. So we can say it removes people earlier in the list. So remove prime Beppy from S should be S names equals Buppy, which is our current element, and Bippy. But also the IDX should have moved back so that the current person should still be Buppy. If I run this, I think it'll fail because the index shouldn't match. So remove people in list failed, and indeed it's just the index that doesn't line up. So back to our actions. In fact, before I do the actions, I'm going to write the other test cases now that it's working. Then I can think about how to implement it. So I have thought about it, but I can think about it some more. It removes the current person and not at the end of the list. So remove prime Buppy from S, and that should be shouty. Should be S names equals Beppy and Bippy, and this time Bippy should be the current person because that's the full list and the index stays at 1. And then we can say it removes the current person. This is going to be awkward to test actually. At the end of the list. Let's go with that. This is obvious from the implementation. Well, it's not that obvious, but it's obvious in the next test what's going on here. Okay, so remove prime. So the reason this is a bit hard to test is if we do Bippy, who's the last person in the list, and then S, but with IDX equals 2, that should be S of names. This is going to be a shuffled list. That's the only problem here. So names is going to be, who do we have left? We have Beppy and Buppy. Let's imagine they're going to get shuffled somehow into this order. I don't know how I'm going to enforce that. IDX equals 2. Maybe actually we'll return the same order of list. Leave the index there for seconds. Trouble is I can't guarantee what the output of shuttling will be, although if I control the seed, then potentially I can. Like I can just run it with a fixed seed and see what the answer is. And given I'm thinking about moving the seed into the state anyway, maybe now is the time to do it. So I'm going to set it up such that it shuffles the list into this order. So the index shouldn't be 2, the index should be 0. We should have gone back to the beginning. Okay, so run those tests. I should have 3 failures. No, I should have 2 failures. The current person should be fine. So people are in the list, I'm not taking the index back, and person at the end of the list, I am not shuffling, and I'm not resetting the index. Okay. At least what I expected, so that's, I guess, some kind of progress. So go back to actions. Suppose I'm going to do, what I was thinking of doing is removing names one by one, and then each time work out what the action, like if I need to take further action, so do I need to decrement the index, or do I need to shuffle the list and reset? So maybe I can have some kind of function sketching this out, but if it's something like remove prime prime, going to take a single name and a list of names, and it's going to return like a remove state. Not state's not a good name for it, but a remove scenario, remove type. Don't know what to call this. And a list of names, so some composite thing. In fact, remove action. So I could say data remove action. It's not going to be data. I think it's going to be new type. Actually, just type data because the language server will fix it for me to get it wrong. New type. It's going to be a single composite type, so it's going to be like a remove. I'm going to call this remove action. I'm going to call this remove outcome. I'm going to call this remove type, and then list of names. So I think I can say data remove type is remove before or remove after or remove current or remove current from end, remove current as last. I don't know what to call it. This needs a constructor before the type. So remove outcome of that. I think. So remove prime of name and names. So it's almost delete, but not quite. So we can say case position of and then I think, can we put a guard in here? Maybe we want multi-if, I don't know. What I want to say is like, oh, we don't need names, so we want state here because we want to compare it to the current index. So I will change this to be auto state. What's the problem? Constructed new type must be exactly one field. Okay, so it's not new type. It's data. Yes, RT of that. So RT is going to be a remove type, so we can say remove before is, so we need to remove outcome, so it's remove before. Well, what's the point of matching these and just writing them in? Doesn't make any sense. I think I'm just pushing the problem down the line. I want something like if the index, I don't think that's the right thing for index, but of n in our list if that's less than the IDX of our list, IDX of our state, then so I can maybe do some guards. And then not use then, but say equals. So it's before, then we have a remove outcome, remove before, and then our new state, so it's going to be s where names equals delete, n from names s, a lot of warnings in there. If idx of n inside names is less than, it's not idx, I better look it up for I write it many times. So I want to say how do you find where something is in the list? Oh, there's something about it. Exception list. lm lookup. Nope. Find filter. No. Indexing lists. Okay. lm index. Yeah. Okay. lmx is going to return a maybe int. Oh, how do you do this? Okay. I'm going to use a where clause. I'm going to say I can't call it IDX because that's really in scope for this. I think I'll call it the index of the thing we're deleting. No. Is I'm going to use lm index of n in the names of s. I'm just going to grab that. Let me do delete index. And let me just put another wise in there to show that for a second. Move outcome, remove after s names equals delete and names of s. Okay. Oh. I assume that was complaining because of something. I've imported IDX. No. Yeah, I'll do that. Okay, now, yeah, that's right. Okay, so this is a maybe int, but I want it to be an int. What do you do if it's not in the list? It's a good point, actually. So one of our remove types, be not found. And then we can say match like that. No. Can we do from maybe? But then I need to take a default, doesn't it? Oh, I want to go from a... I want something which says, I know it's a just give me the value of that. So IDXS if I did that and then that, is that going to work? Nope. Oh goodness. Applied just to that. Nope. Oh, Haskell's complicated. So maybe I will use my case statement here. Case del IDX of, so nothing will be remove outcome, remove before. These are a bit long. I might just move it to a helper as well, so new state. New state. But I don't want to do the whole state. This is really annoying. I don't want it to go to that. I want to go to list of names because I don't want to worry about updating the state inside here. So maybe we can take like current index, which is an int. And call this new names. Second. New names is delete n from s. And oops, it's not s, it's my names. Okay, and now there's no point in moving it to helper because it's just a one-liner or just a one function thing. Index n of ends of nothing. Otherwise, I'll say remove outcome not found. And we'll just return the original names. And this will not be auto state anymore, it's going to be list of names. Right, so nothing is fine. If it's just if it's just I and I is less, oops, not I, that'll be the current one. It's just X and X is less than I. Can you do that? Yeah, I don't think you can do that. So you just get this horrible nested thing. Case X of This is wrong. This is not found, and its original names. I just want to apply some guards to this X. That's annoying. Because really I want to say like, oh, I could do, no. I want to say like just X where and X is less than I. I mean, it was before. But that's more difficult than I thought. How would you apply a guard to a case? Can you apply a guard to a case? And guard a function, I could just put it in a function, I guess. In case, in both after a pattern and before the body. Oh, okay, so I can say just X and then a guard. So X is less than the current index. Okay, that's what I want, I think. Move outcome is remove before, and then oops, new names. Okay, just X where X is greater than I is remove outcome, remove before, new names. Then we can say just X where I is not equal to the length of names. I probably need to spell length correctly, and also not quite that, is it? Because it'll be I plus 1, because this is the offset into the list, so it's always 1 less than the length. So for the last element, remove out. In fact, we could say, we could write this slightly better, so we can say if it's less than the length. Now you got some problem on you. Sorry, this is removed after. I'm going to jump around fixing errors as we go. This is remove current as last. And the last case is remove outcome. Got the names. Remove outcome, remove current names. Okay. Wrong syntax. Done bracket, please remove it. And then is that? No, not that. Not that either. That's what we want. Just line those up. Kind of hope that the formatter did it for me, but it doesn't. Okay. Oh, the formatter hates that. It's fair enough, it is pretty terrible. Okay, so what's this going to do? It's going to remove this thing from the list, and it's going to tell me where it removed it from. So now I hope, if this was a single name, in fact, I'm going to just cheat. Now it's a single name. Okay, so we're removing a single name. We've got NNS, so we can say something like case remove prime of, then we just match against this, so you can say remove outcome, remove before. I don't like having a second constructor actually. What I'm thinking is, if I just add the names to these things, then I can drop out my remove outcome. In fact, I can rename this to be remove outcome. I can get rid of that. Just comment that for a second because of syntax errors. So here remove outcome, there is no thing here. Get rid of that, and then get rid of that as well. And there's no NS, and it's not found. Okay. So, call remove prime. I'm going to pass in what it wants. It wants the current index. So that's the IDX from S. It wants the name we're going to remove, which is N, and it wants the list of names, which is the names of S. Right. Simple case not found. We just return S, unmodified. Remove before, new names. We want to return S, but IDX is the IDX of S minus 1, and names is the new names. And then remove after is the easy case. Using names is NS. Actually, remove current is easy as well. S of names equals new names. And then remove, this is when it's hard, so remove current as last. We are going to return S. IDX is 0. IDX is 0 and names. I'm going to set it to the just new names in a minute, even though it's wrong. Planet hint. This is wrong. I've got the brackets because it's a list of names. Okay. So we try to remove something that's not found. We don't have a test case for this, but it doesn't change anything. Before, it returns new names and drops the index. After and current say the same. And then remove current as last will fix the index, remove the thing, but it doesn't shuffle the list yet. So I run that. I would expect 3 of them to pass and the last one to fail because the list is not in the same order or the correct order. 2 failures. Okay. So there's a current person. Current person. We should not have modified the index for the current person. And it removes current person in the list. It did not modify that. So I think I'm identifying the end of the list incorrectly. Let's check that. So current person, we've taken out the list. It's correct, but I haven't dropped the index. Or I've set it to 0, actually. I think it shouldn't have changed the index. So it looks like that's matching the end of the list one. And here, it has dropped the person at the list, hasn't shuffled it as expected, but it hasn't changed the index. Okay. So I think this is wrong. So the index we're given, is equal to or is it not equal to? So did that help? Now we should have 1 failure, hopefully. So the shuffling. That's better, I think. And it's the last person. So index is correct, but we're just not shuffling the list. Okay, so how are we doing? Running a bit late, but let's quickly see if we can put our seed into here, which is an int, but it's not really an int, is it? Because if I go back to my lib, this shuffling, what's the type of seed? Oh, it says it's an int. Okay, that's cool. And if I can shuffle, it takes an int, doesn't it? Yeah. Okay, so I'm going to do that. Initial state is under IO, so I can just I can go and cheat and grab this. That's not cheating. Not let it, just do it. And then we can say in here, seed equals seed. And grab that and that. Okay, but more importantly, in our spec, hopefully, we can put a seed into here and just keep changing it until it gives us the right answer. So seed equals 1. Oh, it needs to import seed as well. Just see, I haven't fixed the test yet. I haven't fixed the implementation yet, so the test should still fail. Just to make sure it still compiles and runs before I touch anything else. Yep, that's good. Hasn't shuffled it. Okay, cool. So now we go back to actions. In this case, names should be shuffle. Is shuffle the right function? Shuffle takes a seed and it takes a list of names and then it's going to sort it for me. So shuffle seed of S and names. Go and add that. Okay, and then go, whoops, don't go anywhere, I can just run the test. Nearly there. It still failed, but I'm not getting to the silliness of changing the seed in the hope that eventually it will give me the right answer. Shame it's got to recompile the whole thing every time, or that it's not faster, basically. There we go. Seed of 2 does work. Seed 2 shuffles correctly. leave for the test. Okay, so cool. So I've written some tests. I've written possibly quite a clunky implementation. I'm not sure about this. It ended up being more complicated than I expected. But it kind of works. I've broken it because it only takes a single name now rather than a list of names. But we can have a look at that next time, I guess. See if we can fix that up. Either work out how to do this across a list of names, which would be interesting because we don't want to shuffle multiple times. We'll see. But yeah, so I got my tests. I have a new implementation, and it does the right thing for removal in these different cases. So I think we're good. So yeah, cool. Got some progress. Maybe not as much as I wanted, but that's the fun of learning stuff, I guess. Cool. So yeah, hopefully you can join me next week where I'm going to fix this mess I've created. Thanks for watching.